Welcome to 5.03. We're going to be working on writing an exponential function given a graph or a table. So to get us started, let's go ahead and practice something that we just finished learning, which is graphing exponential functions. So here we're going to graph each function. I've labeled them y sub 1, y sub 2, y sub 3, and y sub 4. And do the best you can to sketch a graph of each of these without making a table. So you should only need to plot that one point where the exponent is 0 and then be able to plot the rest of it, to sketch the rest of it, just knowing what it will look like based on the values of the constant terms. All right. First three are fairly simple. I know that they're all going to go towards 0 as I move towards the left, and up towards infinity as I move towards the right, or as x approaches positive infinity. And for the first one, I know that I'll have an exponent of 0 when x is 1. So there's that point. It moves up to the right, towards 0 to the left. Here I have an exponent of 0 when x is 0, and I'm adding 2, so that y-intercept will be at 3, up towards the left, down towards 0 to the right. Here I have an exponent of 0 when the x value is negative 1, so that's a translation to the left of 1 unit, and 3 times 1 is 3, up to the right, towards 0 to the left. Here I have a negative exponent plus 1, so negative x plus 1. So this is a little tricky, but what I've got to remember is that just take it step by step. So I know since I have a negative x value here, that it's going to move towards 0 as I go towards the right, so as x approaches infinity, my value, my function is approaching 0 because I'm going to have a bigger and bigger negative exponent. It's going to get closer and closer to 0, and as I move towards the left, it's going to get towards positive infinity. But I have a shift to the right of 1, and this is tricky. You might want to say to yourself, oh, it should be to the left, but what you've got to remember is I need to test the value that will make my exponent 0. Well, this will be an x value of 1. 1 plugged in here will be negative 1 plus 1, which will be 0, and so that's the point that I'm going to plot, and then I can graph my function. So now we want to move towards graphing, away from graphing and towards writing our own exponential function using a graph, or perhaps a table. We're going to start with the graph. So what we want to do here is we want to write a function, an exponential function, so a times b to the x, that will create this graph. And so in order to do that, we need to figure out what the values of a and b should be. And so I want you to pause the video right now and go ahead and try this on your own. It doesn't matter what method you choose. Just give yourself 2 minutes and give it a try. Alright, so this can be kind of tricky at first. You've got two constants that you don't know yet. You need to figure out this a and b value so that you can create your function. And you'll notice that I don't have, a times b to the x minus k plus c, all this other stuff. And we're going to start with some fairly simple ones, and almost always we won't need to write that minus k up there. We'll be able to find a function to model this without the minus k. When we're creating functions ourselves, we will actually want to include that sometimes to make it model real life. But for now, we don't really need to worry about it, and you'll understand as we move on towards in the unit. And here there is no c value. It just says in this form, so we need to find the a and b values. And what we want to do is pay close attention to some of the points that we're given. And the most important point that we're given is when the x value, when the exponent is 0. And we're able to ascertain what the value of the function is when my x value is 0. So I want to write this information down. When I plug in an x value of 0, f of 0, that will give me a times b to the 0. And what does that have to equal? Well, that must equal 3. Right? That's what the graph shows me. That is equal to 3. Right? Well, this actually gives me some information. Pause the video and try and see what information you now have. You'll notice that anything to the 0th power is 1. So I have a times 1 equals 3, which means that my a value must be equal to 3. And that's important because that helps me get part of the way towards my function. So I know f of x, my function, is going to be 3 times b to the x. And now I only have one more value that I'm looking for. I need to figure out what would this b value, what should this b value be? And what I can do now is use the function that I've already got. So I know what the a value is at this point. I know that f of x is 3 times b to the x. And so now I can use this function to help me find the last piece of missing piece of information that I don't have yet. How can I find this missing b value? What you'll realize is there's only one thing we're missing, and we have another point. We even have 2 points that we can plug in, and if we plug in these points, we'll notice that the only thing we'll be missing is that b value which we're trying to solve for. So in plugging in that point, let's choose the first one, f of 1. When x is 1, I'll have 3 times b to the first power equals 6. Well, b to the first power is just b. So I have 3 times b equals 6. 3 times b equals 6. Divide by 3 on both sides, and I get that b must be 2. So my function, f of x, is equivalent to 3 times 2 to the x. And you could have used the other point to solve this as well. So you could have used the point that I'm given here. And I want you to go ahead and try that now on your own. So redo this second step using this other point here to find the missing b value. And you'll see that you can go ahead and solve this out. Notice that I end up with b squared equals 4, and that what squared equals 4? Well, either plus or minus 2. And what we've been using in the past is we always take the principal root, or the smallest positive value, and so b should be equivalent to 2. And so there's my function, 3 times 2 to the x. Alright, so here is a slightly different question, but it really is asking us the same thing. We want to use the table below, which contains some of the points from an exponential function, and write the function in the form f of x equals a times b to the x. So I want you to pause the video right now and see if you can utilize some of the strategies that we just worked on to come up with the function, and then go ahead and press play and see how it looks. Okay, so remember, what we need to do is determine the value of the constants a and b so that our function will follow through these points. And it might be helpful to begin with just to kind of sketch what this graph will look like. So at -3, I'm up at 40. At 0, I'm at 5. And at +3, I'm at 5/8. So you can imagine, since it's an exponential function, that it will look like that. Now, when you see this, you will notice a couple of things. The first is that this is always positive, so the a value you're expecting should probably be a positive value. The second is that as I move towards the right, my values are getting smaller, and as I move to the left, my values are getting bigger. So you might think about, what could my b value be? Well, if every time I'm raising it to a higher power, it's getting smaller, my b value must be less than 1. And if every time I raise it to a negative power, it's getting bigger, that's got to be less than 1. So I know already what I'm expecting, and that's very helpful. And so now I can just go and actually find them. So first thing I'm going to use is the initial point when my exponent is 0 to find the a value. So I have a times b to the 0 is equal to 5. Well, b to the 0 is 1, so a times 1 must be 5, and therefore a is 5. So at this point, we know that f of x is equal to 5 times b to the x. And now we go ahead and use another point to find the b value. So I will encourage you again to pause the video and choose a b value to plug in. Either one will work. Maybe choose both and see how it goes. All right, I am going to go ahead and choose the negative one because I think the either one will work, but let's just work with the negative. So if I plug in negative 3 into my function, I will have 5 times b to the negative 3 is equivalent to 40. All right, so let's see what we've got here. We have 5 times b to the negative 3 equals 40. So if I divide by 5 on both sides, I'll have b to the negative 3 is equal to 40 divided by 5 is going to be 8. So now I am in a little bit of a tricky situation because what I need to do is solve for b here. So I have this exponent of negative 3. What am I going to do with that? So I encourage you to pause the video again and think about how you can solve this. All right, there are many ways that you could go about solving this that are correct and will get you the right answer. What I always like to think about is that my exponent is negative 3. And what I eventually want is I just want b raised to the first power. That's what I'm trying to solve for. And so I need to get b to the first power on the left side of my equation. Well, what do I have to do to negative 3 so that it becomes, so I end up with 1? Well, I need to multiply by some value, and so I need to raise to an exponent that when I multiply by negative 3 will give me 1, which is going to be negative 1/3. And now I will be able to do that on the other side of my equation, so I'm going to raise 8 to the negative 1/3 power as well. So b is going to be equal to 8 raised to the negative 1/3 power. And you might say, okay, well, what is 8 to the negative 1/3 power? And I encourage you to go back and remind yourself what to do with negative exponents. 8 to the negative 1/3, I'll show the work over here. So 8 to the negative 1/3, since it's a negative exponent, it's 1 over 8 to the 1/3 power. Well, what's 8 to the 1/3 power? 8 to the 1/3 power is the cube root of 8. So it's 1 over the cube root of 8. What's the cube root of 8? Well, the cube root of 8 is 2, so I have 1 over 2. And so b is equivalent to 1/2. Let me write that a little more. 1/2. So my function, f of x, is going to be 5 times 1/2 to the x. All right, I'm now going to give you 2 questions to do on your own to practice. And remember that we are going to have a quiz on Wednesday, so make sure that you take your time, post a comment which has a question or an answer to someone else's question. Right. Here are two questions for you to try. Remember that we're using an exponential form here, a times b to the x, so you can use some of the skills that you've just developed to write functions to model both the graph here and the table that contains 2 points from an exponential function.